Hello, my name is Eduardo Rios, and this is the schematics and waveforms presentation for Lab 1. So here I have the half adder. Um, Remove this. As you can see, A equals 1. Just moves it 1 from 1 to 0. So 1 plus 0 is 1, no carry out. 1 plus 1 is 0, carry out of 1. Then if you flip it, and you get 0 plus 1 is 1, no carry out. So that's how the digital schematic works for that one. And then instead of going to the waveforms, I'm just going to go to the rest of the schematics. And let me open recent. So that's the half adder. Let's do the full adder. Now the full adder includes a carry in. So let me run it. So here we have 0 plus 0 plus 0. So 1 plus 0 is obviously sum of 1. Light green means 1, dark green means 0. 1 plus 1 now is going to give you 0 with a carry out of 1. And if you add 1 more, it's going to be 1 plus 1 plus 1, which is obviously 3. So it's going to give you a sum of 1, and it's going to give you a carry out of 1. And yeah, you can flip it. And now if you just want to turn one of the inputs into 0, now your sum is going to be 0 and your carry out is 1. So the carry in just acts as an extra input, just gives you the extra benefit of having a 1 as a carry it. Well, 1 and 1. And then the next one is going to be open and recent, the incrementer. And now, as the name suggests, it just adds 1, but now it has a half adders and it includes wires of inputs of 4. So, for example, if I want to do 4, right? Okay. And I want to add 1, goes up to 5. 4 plus 1 is 5. Or let's say, for example, you want to have A. This deals with hex digits. A, which is just 10, add 1 more. Add 1, it goes into B. And there is no carry out. Let's see. F. There we go. Now F plus 1 does give you a carry out just because it is dealing with unsigned numbers, and there's too many bits of it. It can only hold up to F. So if you can imagine, it's the that's the binary component of F is 1 1 1 1. You add 1 more, you're adding an extra bit, and it doesn't have that, so it has a carry out. And if you take that away, the carry out goes to 0, and it's just F because F by itself is that. So yeah, that's how that works. And you go back to 0 1, and as you can see, there's only a carry out. There's only a carry out when you go to F, because that just shows that there's too many bits. And that leads us perfectly into the 4-bit full adder. And now, as you can see, now we have the full adders there, and this is the biggest part. This is the last schematic. So here you can add any number. For example, you can add positive numbers. 3 plus 2 gonna give you 5. And if you want to increment it, add 1 more, it gives you 6. You can add negative numbers. You go here, you add 9, which is just negative -7. And then you can add it with -1. Obviously, the program doesn't do that. It doesn't add it as signed numbers, as unsigned. It gives you out 9. It has a carry out of 1. No overflow. You can add 1 more, and it goes up to 8. I'm sorry. You can take it. You can add a carry in. It goes up to 9. You take it away. It's just 8. But yeah. The program, specifically the schematic, it for the overflow, it works like a two's complement sign number, which means if the carry out and the last digit is the same, there's no overflow, but if they're different, there is. So you can have 0, 0, or 1 and 1 means no overflow, but if you have 1 and 0 or 0 and 1, that is going to be overflow. And the carryout just works with unsigned numbers, which is if you have a carryout, it counts as a carryout. Now, with that said, let's go ahead and give a look into the GTK waves of all four schematics. Let me go ahead and open it. And then after that, I'll go ahead and share my screen. Share, and then I'll share my whole desktop. Here we go. You go ahead and run GTK wave. Okay, file, open a new tab. And we'll start off with the half adder, as I did beforehand. Sum and carry out. Now, as you can see here, same rules apply, just shows it 0 plus 0, a sum of 0, no carry out. 0 plus 1 equals 1. 1 plus 0 equals 1, no carry out. 1 plus 1 is 2, so it has a sum of 0 and then a carry out of 1. So that's a half adder, goes to show it. Let's run it one more time, show the other three. ZK wave, while open your tab. Half adder. Let's do the full adder next. ECD. Full adder, full adder. A, B, carry in, yes. All right, here we go. A and B, 0, 0, no carry in, no sum. A, B, you add one carry in, you get a sum. Here shows 0 plus 1 plus 0 just equals 1. Here shows when one of the inputs and the carry-in is 1 plus 1 is going to be 0. 1 plus 1 is 2, so it's just 1, 0, with the carry-out being 1, summation. And then here over here at the end, you can see that you have both inputs equaling 1 plus the carry-in equal 1, which is just 3. And that's going to be a sum of 1 and then carry out of 1. Um, let's go ahead and show the last two. Okay, wait. Next one that I'm going to be showing is going to be the incrementer. Incrementer, a one, so here it shows the incrementers, basically just flips it, as you can see. 0 plus 1 is just 1. 1 plus 1 is 2, 2. It just increments it by 1. And then if you go down, and let me zoom this out, as you can see, it flips here. It goes from F plus 1, just goes back to 0, because it's just, it overflows. And that's where the carryout comes in, and then it just restarts. And from that point, it just goes back to normal. It goes and flip-flops between itself, 1, 1, 2, 2, 2. That's the incrementer. Very simple, the easiest one to explain out of the bunch, because it's just adding 1. And then the last one is going to be the 4-bit adder. Oh, didn't mean to do that. So here we have A, we have B, we have the carry-in, and then we have the carry the answer. Then we have the carry out, and then the overflow, of course. See if I can make it smaller. Let's make it bigger for now. Okay. So here it's going to show basically the same thing, but now it's adding, you can add negative numbers, still 4 bits. Now you can add unsigned numbers from 0 to F, which is just 0 to 15, or you can add Sign numbers, which is 0 to 7 positive, 8 to F being negative. Now, as you can see, 0 plus 0 plus carry of 0, and it's gonna give you a zero, it's gonna give you the output of 0, no carry, no overflow. But interesting, in the second one, you have 1 plus 1, no carry in equals 2, no carry out and no overflow. And for something like here where it says 8 plus 8, when you do it, when you do the summation by hand, it gives you a summation of 0, but it does give you overflow, and that is through the sign of um what's it called? There being no carry out. However, there was a carry in that was passed over in the last place before it finished. So that's how it happens. So for the overflow, it focuses on the properties of a signed number, while the carry out focuses more on an unsigned number. You have an unsigned um, hex number when you're adding them together. So yeah, here's the full schematics, the whole full wavelengths of all four. And yeah, that has been my presentation for lab one. Thank you for your time.